Quantitative literacy. This is the second video for 12.5b. Now we're getting into word problems. So we have a fruit packing plant producing peaches. Mean weights were 14 ounces. Remember that mean is in the middle of the curve. So 14 ounces is the middle. And a standard deviation of 0.6 ounces. Okay, so for all these problems, we're looking at a sample of 2,500 peaches. Keep that in mind. For part A, this one's easier. How many peaches would have a weight of at least 14 ounces? Well, basically, that's just saying, since 14 is the middle, at least 14 ounces would be 14 or more. So it would be just the right side. Since we know this is perfectly symmetric, we know that's 0.5, or half of the peaches. So really all I'm doing on 4A is figuring out what 0.5 of 2,500 is, or what half of 2,500 is, which would be 1,250. Again, that's the amount of peaches I can expect. The rest of these get trickier. So for letter B, a weight less than 13.2 ounces. Okay, well, looking at my curve, I know 13.2 is smaller than 14. So 13.2 ounces, again, I don't care where you draw it as long as you draw it to the left. 13.2 is somewhere over here. And I want to know the peaches less than 13.2. So I want this part of the curve. Now here's the problem. 13.2 is not a z-score. I cannot go to my table and look up 13.2 because it's not a z-score. This is where we have to go back to the z-score formula that we had previously, which was z is x minus the mean over the standard deviation. That's going to be the name of the game on all of these word problems. Try that again. We have to first figure out the z-score. So what do I mean? I have to take 13.2 minus, 13.2 minus the mean, which is 14, and divide by the standard deviation, which it told me in the problem was 0.6. And now we're always going to take our z-scores to 2 decimals because the z-score table only goes to 2 decimals. So if you run this in a calculator, and be careful, make sure you either put the top in parentheses on your calculator, or you do the top, hit enter, and then divide by 0.6. You should get that 13.2 goes with a z-score of negative 1.33. So now I'm going to go to my table for 1.33. Remember, my table only tells me positives, but I'm going to go to 1.33 for a z-score. Right there, that goes with an area of 0.408. 0.408. Now, that is this part. Notice I want the red part on the other side. Remember, half of the area is over here. So I'm going to have to do 0.5 minus 0.408. 0.408. That's going to give me the red area, which is 0.092. That's the area of the red. I'm almost to the end of this. So I'm basically saying 9.2% of the peaches are supposed to weigh less than 13.2. But remember that on the actual question over here, it wants how many. So I have to figure out what 0.092 of 2,500 gives me. And we're going to round to the nearest peach. If you get a decimal, it'd be about 230 peaches. Again, imperative that you draw a curve and shade what it is that you're supposed to be finding. Label numbers on the axis. Shade what it is that you're finding. For letter C, now I've got two weights. 14.9, so 14.9 is going to be past 14 somewhere. And 15.5, so that's still going to be past. So this is one of those where I want to know the in-between, and they're both on one side of the curve. Well, before I get to anything else, I've got to convert these over to z-scores. So again, I'm going to use the formula, but I have to do this with both. 14.9 minus 14 divided by 0.6. That will give you a z-score of 1.5. If I find the z-score that goes along with 15.5 minus the mean divided by the standard deviation, that gives me a z-score of 2.5. So how did I do this on the first video? I went with the bigger z-score, 2.5. If I go to my table, 2.5, it's on the second page. 2.5 goes with an area of 0.494. So remember what that means is all of this red area, all of that red area is 0.494. But that includes this blue area that I don't want. So I'm going to find that blue area, which means I've got to go to 1.5 on my table. 1.5 on my table goes with an area of 0.433. So that blue area was 0.433. I want in between those, which means, again, I'm going to subtract off the blue area. If I subtract off the blue area, that will give me the in-between that I want, which is 0.061. So basically it's saying 6.1% of the peaches are between 14.9 ounces and 15.5 ounces. And the very last step would be to say, okay, what is 6.1% of 2,500? And so I multiply that. That will give me a decimal. I'm going to round it to 153. I believe it's 152.5. So I rounded it to 153. For letter D, again, important that you draw a curve and you shade what it is that you're trying to find. You label your axis with all the important numbers. We know 14 goes in the middle. So now one's between 13. So 13 is to the left of 14. And 15. 15 is to the right of 14. Okay, I've got to convert those to z-scores using the formula. So 13 minus 14 divided by the standard deviation. That'll give me negative 1.6 repeating. Again, I'm going to round to 2 decimals. So that'd be negative 1.67. For the number 15, I've got to convert that to a z-score. 15 minus the mean, 14, over 0.6. That's going to give you positive 1.67. So this one, I'm not going to be doing a subtracting. I'm going to be doing an adding process because I want all of the in between. So from 13 to the 14, and I want from 14 to 15. I want that total. Well, here's what's nice. Remember, negative and positive z-scores have the same areas to the middle. So I'm just going to look up 1.67. Oops, went too far. 1.67, there it is. That goes with 0.453. So that tells me the blue area is 0.453. The red area is also 0.453. And again, I want both of those on this one, so I'm going to add those. If you add those together, you get 0.906. So it's basically saying 90.6% of the peaches are going to be between 13 and 15 ounces. So I have to figure out what 90.6 or 0.906 of 2,500 equals, which will give me about 2,265 of the peaches. Okay, that's where we'll stop this video. We'll do one more video for the last problems.